Look up into the night sky. That bright, steady light gliding overhead? It's the International Space Station. For over 20 years, humans have lived and worked aboard this outpost, circling Earth every 90 minutes. The ISS is a marvel of engineering and a symbol of our drive to explore. Built by 5 space agencies and more than 15 countries, it's a city in the sky, assembled piece by piece, module by module. Astronauts aboard conduct research impossible on Earth, pushing the boundaries of science and technology. The ISS is more than hardware. It's a testament to human ingenuity, perseverance, and our shared spirit of discovery. Our foothold in the final frontier, the ISS marks humanity's continuous presence in space. The ISS is more than a technological feat, it's a beacon of international cooperation. Astronauts from the US, Russia, Europe, Japan and Canada live and work together, united by science and survival. On board, national borders fade. The mission transcends politics. From the Cupola, crews witness Earth's beauty and fragility, forging a bond that reminds us we're all crew on the same planet. The ISS proves that our quest for knowledge can unite us, inspiring new generations to reach for the stars. Its greatest legacy may be the hope and connection it brings to humanity. The ISS stands as a monument to peace, cooperation, and our shared future. The ISS began not with a launch but with an agreement, a promise among nations to build something unprecedented. In 1988, the US, Canada, Japan, and Europe signed on to create a permanent outpost in space. This partnership required merging cultures, engineering, and laws into a single vision. The agreement was a blueprint for peaceful collaboration, shifting from rivalry to unity. Each nation contributed vital components, trusting one another to assemble a city in the stars. The ISS was designed as a laboratory for all humanity, a symbol of what we can achieve together. The first handshake was on paper, the next would be in orbit. The end of the Cold War brought a new partner, Russia. Former rivals, the US and Russia joined forces, combining expertise from Mir and the shuttle programs. Russian Soyuz and Progress spacecraft became lifelines for the ISS, ensuring its sustainability. Engineers bridged language and technical divides, building trust where suspicion once stood. The shuttle Mir missions were dress rehearsals, teaching crews to live and work together in space. This alliance proved that even former adversaries could unite for a greater cause. The ISS became a truly global project, built by hands once divided, now working as one. The ISS took shape in November 1998, when Russia launched the Zarya module, Sunrise, into orbit. 2 weeks later, the US Space Shuttle delivered Unity, the first American connecting node. High above Earth, Zarya and Unity were joined, a Russian Sunrise meeting American Unity. Astronauts performed spacewalks to link the modules, forging the station's foundation. On December 10th, the first crew entered the new station, a silent 2-room home awaiting its future. This union of steel and circuitry was a powerful symbol of international partnership. The ISS was born, its first bricks in place, ready to grow into humanity's home in space. With Zarya and Unity in place, the station orbited unmanned for 2 years as components like the Zvezda service module were added. This changed with Expedition 1. Commander William Shepard, and Russian cosmonauts Yuri Gidzenko and Sergei Krikalev. Their mission? Homesteading. They activated systems, unpacked equipment, and transformed modules into a habitable environment. Training was rigorous, spanning the US and Russia. On October 31, 2000, they launched from Baikonur Cosmodrome. Approaching the ISS, they saw their new home. They began an unbroken chain of human presence in space. On November 2, 2000, the Expedition 1 crew docked with the International Space Station. Commander Bill Shepard, Yuri Gidzenko, and Sergei Krikalev floated into the station, making it the first time the station had residents. Humanity had established a permanent foothold in low Earth orbit. Their first days were a whirlwind, activating life support, communications, and scientific equipment. Life aboard was a blend of hard work and breathtaking beauty. Expedition 1 was a success, proving humans could live and work effectively in orbit. Their legacy is the continuous human presence in space. Expedition 1 marked the beginning of life aboard the station. To grow into the scientific laboratory it was designed to be, it needed a massive boost in electrical power. This arrived with the Space Shuttle Endeavour on mission STS-97. Tucked inside was the P6 truss structure that held the first pair of giant American solar arrays. These colossal golden wings, each one stretching an incredible 115 feet, convert the sun's energy into electricity. The installation was one of the most complex construction tasks yet undertaken in orbit. The most dramatic moment of the mission arrived: the unfurling of the solar arrays. Slowly, majestically, the two golden blankets of solar cells began to deploy. As the arrays reached their full span, the International Space Station was visually transformed. The successful deployment was a monumental milestone. It immediately more than doubled the station's available power, paving the way for the arrival of the first major science laboratory. The International Space Station needed a skeleton. The first piece, the S0 Truss, arrived on mission STS-110. It was designed to be the central anchor point for the Truss system. Installing it transformed the station into a sprawling horizontal complex. This required the first ever use of the station's robotic arm, the Canadarm2, to perform a handoff with the shuttle's robotic arm. 4 spacewalks were needed to secure the truss and connect its power and data cables. With the S0 truss in place, the ISS had a new centerpiece. This mission proved the capabilities of the station's robotic arm. The station's silhouette changed, now featuring the beginnings of its iconic framework. Tragedy struck on February 1, 2003, when the Space Shuttle Columbia disintegrated upon re-entry, killing all 7 astronauts. The entire shuttle fleet was grounded, devastating the International Space Station, which relied on the shuttles for assembly. The ISS shifted to maintenance, relying on Russian Soyuz and Progress spacecraft for survival. NASA worked to improve safety. And on July 26, 2005, Space Shuttle Discovery launched on the return-to-flight mission. The ISS assembly could finally resume. In 2001, after 136 days in orbit, the Expedition 1 crew prepared to return to Earth aboard the Space Shuttle Discovery. As Discovery backed away, a fly-around gave a full view of the ISS, showcasing the Zarya, Unity, Zvezda modules, and the Destiny laboratory. This bittersweet departure marked the success of the first long-duration stay, proving international cooperation worked. The iconic images captured showed the ISS as a living outpost, a beacon in space, continuously tended. With the Space Shuttle fleet back in service, the assembly of the International Space Station resumed. September 2006 marked a period of intense construction, exemplified by Space Shuttle Atlantis, STS-115. This flight delivered the P3/P4 truss segment with a second pair of giant solar arrays. The primary task was a series of demanding spacewalks to install and activate this new hardware. A stunning photograph captures the essence of this incredible endeavor. This image powerfully illustrates the scale of the ISS and the courage of the individuals who built it by human hands. The successful installation of the P3/P4 truss and the deployment of its solar arrays marked a significant leap forward. The resumption of assembly signaled that the ISS was back on track. Its growth no longer stalled. In 2007, the station's backbone grew significantly. Space Shuttle Atlantis delivered the S3/S4 truss segment. Its installation completed the station's integrated truss structure, extending the railway and adding the third solar array wing. The mission faced drama when computers controlling the station's orientation crashed. The ISS was adrift, relying on the shuttle's thrusters. Spacewalking astronauts installed the truss and prepared the solar arrays. The mission was a success. The S3/S4 truss was in place, its solar arrays unfurled. This cleared the path for the arrival of European and Japanese laboratories, transforming the station into a global research center. The year 2008 marked a pivotal moment for the International Space Station. In February, the European Space Agency's Columbus module arrived, a state-of-the-art laboratory for life sciences, fluid physics, and materials science. The addition of Columbus transformed the ISS into a world-class scientific facility. In March, the first part of Japan's contribution arrived. Then, in June, the main pressurized section of Kibo, the largest single ISS module, was delivered. Kibo offered a unique airlock and exposed facility for experiments in the vacuum of space. One of its most beloved features was its stunning Earth-facing window. With Columbus and Kibo, the ISS was complete, a truly international workplace. For the first 8 years of its life, the International Space Station was home to crews of only 2 or 3 people. While this was enough to maintain the station and conduct some research, The limited crew time was a major bottleneck for realizing the station's full scientific potential. The partners had always envisioned a larger 6-person crew, which would dedicate hundreds of more hours per week to experiments. The year 2009 was the culmination of a multi-year effort to upgrade the station's life support systems to finally make this dream a reality. It was the year the orbital outpost truly became a fully staffed, round-the-clock research laboratory. Making the station a home for 6 required significant upgrades to its environmental control and life support systems. A new, advanced water recycling system was installed, designed to reclaim wastewater from urine, condensation, and hygiene activities, and purify it into drinking water. This P2-potable system was a critical piece of technology, dramatically reducing the amount of fresh water that needed to be launched from Earth, a key step for enabling future long-duration missions to the Moon and Mars. Additionally, a new oxygen generation system, a second toilet, new crew sleeping quarters, and a new exercise machine were all installed to accommodate the larger population. The final piece of the puzzle arrived in May 2009 when a Soyuz spacecraft docked with the station, bringing 3 new crew members to join the 3 already on board. For the first time, all the international partners, NASA, Roscosmos, ESA, JAXA, and the Canadian Space Agency, were represented on the station's crew simultaneously. On May 29, 2009, Expedition 20 officially began, marking the start of 6-person crew operations. This was a landmark moment. The station was no longer just a construction site or a sparsely populated outpost. It was a bustling, fully operational home and workplace for a diverse international team. The transition to a 6-person crew was a game-changer for science. The amount of time dedicated to research activities more than doubled overnight. This increase unleashed a torrent of scientific discovery, allowing for more complex and long-term experiments in human physiology, biology, physics, and Earth observation. The station finally began to operate at its full capacity, fulfilling the promise made by the partner agencies decades earlier. The lights were on, all the rooms were occupied, and the laboratories were humming with activity. The International Space Station had truly come of age, transforming from a house into a bustling, vibrant home away from home. For years, astronauts glimpsed Earth through small portholes. That changed in 2010 with the arrival of the Cupola, delivered by the Space Shuttle Endeavour. This dome-shaped module boasts 7 large windows for an ultimate observation deck. Installation gave crews a panoramic view of Earth and the station. Using Canadarm2, astronauts moved the module with precision. The view was astonishing, a 360-degree vista of our planet. The Cupola quickly became the favorite spot, the heart and soul of the ISS. Beyond inspiration, it's the primary control station for the robotic arm. This small room blends the poetic with the practical, a window to our planet. For 3 decades, the Space Shuttle had been the symbol of human spaceflight. It launched like a rocket and landed like a glider. It built the Hubble Space Telescope and nearly the entirety of the International Space Station. But its time was coming to an end. On July 8, 2011, the Space Shuttle Atlantis lifted off for the very last time. The final mission was a crucial one for the station's future. The image of the shuttle slowly shrinking against the backdrop of Earth was the end of an era. From this point forward, American astronauts would rely solely on Russian Soyuz capsules. The end of the shuttle era also spurred the development of a new commercial spaceflight industry in the United States. It closed one incredible chapter of human spaceflight and cleared the way for the next one to begin. Before the final flight of Atlantis, another historic shuttle mission provided one of the most unique and breathtaking sets of images in the history of spaceflight. In May 2011, the Space Shuttle Endeavour made its final journey to the International Space Station on mission STS-134. Its primary task was to deliver the Alpha Magnetic Spectrometer, a massive particle physics experiment designed to search for dark matter and antimatter. As Endeavour was preparing to depart the station, an unusual opportunity presented itself. A Russian Soyuz capsule, carrying departing Expedition 27 crew members, was scheduled to undock at the same time. This created a once-in-a-lifetime photo opportunity. The plan was carefully choreographed between the mission control centers in Houston and Moscow. After the Soyuz TMA-20 spacecraft undocked from the ISS, with Italian astronaut Paolo Nespoli aboard, it did not immediately head for home. Instead, it flew to a position about 600 feet away from the station. From this unique vantage point, Nespoli was able to capture a series of stunning, high-resolution photographs and videos of the Space Shuttle Endeavour docked to the sprawling International Space Station. It was the first and only time a docked shuttle was photographed from the perspective of a departing Soyuz. The result was a set of images that looked like something out of a science fiction movie. These photographs offered a new and powerful perspective on the scale and complexity of what humanity had built in orbit. They showed the entire magnificent structure, the long Truss backbone, the giant golden solar arrays, the collection of international modules, and the iconic winged orbiter nestled against it, all set against the deep black of space and the brilliant blue of Earth. The images were a stunning family portrait, capturing the two cornerstones of the ISS program, the American shuttle and the Russian Soyuz, together at the station for one of the last times. They perfectly encapsulated the spirit of international cooperation that defined the project. The view was a powerful testament to the end of the assembly phase. The station in these images looked complete, a finished masterpiece of engineering. Endeavour's presence symbolized the 3 decades of construction work that was now drawing to a close. Paolo Nespoli's photographs became an instant classic, a final majestic tribute to the Space Shuttle's legacy and its monumental role in building our outpost in the cosmos. They provided a unique perspective, not just in terms of camera angle, but in historical context, capturing a fleeting moment when the past, present, and future of human spaceflight were all visible in a single, awe-inspiring frame. Life on the International Space Station involves constant maintenance. In 2013, a cooling loop failed, impacting science operations. The fix required replacing a faulty pump module. Astronauts Rick Mastracchio and Mike Hopkins undertook the urgent repair. On Christmas Eve, they ventured out to replace the module. The spacewalk required extreme care to avoid damaging equipment. The successful repair highlighted the skill of the astronauts. It demonstrated the ISS program's resilience, ensuring our orbital home remains safe and productive. Living in space completely changes your relationship with the planet. You see it not as a collection of countries, but as a single living entity. At night, the Earth transforms into a tapestry of glittering lights, a stark and beautiful testament to human civilization. You can watch thunderstorms erupt, their lightning flashes illuminating the clouds. These views are profoundly moving, showing our collective footprint. Seeing the planet as a single glowing orb reinforces the idea that we are all in this together. It is a deeply human view, one that highlights our shared existence on this fragile world. To see the Earth as a nightlight is to see our home in a way that fundamentally changes you. With the Space Shuttle retired, the International Space Station needed a new way to get supplies. The workhorse for heavy cargo was gone. While the Russian Progress, European ATV, and Japanese HTV vehicles were essential, NASA looked to a new model to fill the gap: commercial partnerships. The agency encouraged private American companies to develop their own rockets and cargo spacecraft to service the station. This was, honestly, a bold new approach, moving from government-owned and operated vehicles to a system where NASA was a customer, buying delivery services from a burgeoning private space industry. It was a major shift in the philosophy of spaceflight. This new era began in earnest in the years following the shuttle's final flight. Companies like SpaceX, with its Dragon capsule, and Orbital Sciences, later Northrop Grumman, with its Cygnus spacecraft, rose to the challenge. After a series of successful test flights, they began regular resupply missions to the ISS. The sight of a sleek, privately built Dragon capsule approaching the station for the first time was a historic moment. It was captured by the station's robotic arm and berthed to a docking port, a maneuver that required immense precision from both the ground controllers and the astronauts operating the Canadarm2. This was, really, the birth of a new commercial lifeline to our outpost in orbit. These cargo missions are the lifeblood of the station. They deliver thousands of pounds of essential supplies on each flight. This includes not just food, water, and spare parts, but also the critical scientific experiments that are the station's primary reason for being. New research equipment, biological samples, and technology demonstrations are packed carefully into these capsules for their journey to space. Just as importantly, vehicles like the Dragon capsule have the ability to return experiments and hardware safely back to Earth, something that had been lost with the end of the shuttle program. This downmass capability is vital for analyzing the results of many experiments. The success of the commercial resupply program has been a game changer. It has proven to be a reliable and cost-effective way to keep the station stocked and productive. More than that, it has fostered a dynamic new commercial space economy, freeing NASA to focus its resources on the next giant leap in exploration, returning humans to the Moon and eventually sending them to Mars. The arrival of each new cargo ship, whether it's a Cygnus, a Dragon or a Dream Chaser, is a testament to this successful new model of partnership. They are the out-of-this-world delivery trucks that keep the lights on and the science flowing aboard the ISS. By 2018, the International Space Station was in its prime as a world-class scientific laboratory. The construction was complete, the crew size was stable at 6, and the commercial resupply chain was robust. The focus was now squarely on utilization, on squeezing every last drop of knowledge from this unique research platform. The station is a place where we can remove a fundamental variable from every experiment: gravity. This allows scientists to study the underlying principles of physics, biology, and chemistry in a way that is simply impossible on the ground. The ISS had truly become a journey of knowledge, pushing the boundaries of what we know about our world and ourselves. A key area of research is understanding how the human body adapts to long-duration spaceflight. As we plan for future missions to Mars, which could take years, this science is absolutely critical. Aboard the ISS, astronauts are not just crew members, they are also research subjects. Scientists study the effects of microgravity on their bones, muscles, cardiovascular systems, and even their immune systems. Experiments like the one launched in October 2018, studying how microgravity affects the intricate workings of the central nervous system, are providing the crucial data we need to develop countermeasures that will keep future explorers healthy on their long voyages into the solar system. The station is also a unique platform for looking back at Earth. With its orbit covering over 90% of the Earth's populated areas, its instruments can monitor our planet's climate, ecosystems, and natural disasters. From tracking the health of forests and coral reefs to providing critical data on hurricanes and wildfires, the ISS gives us a global perspective on our changing world. This information is vital for disaster response, environmental management, and understanding the long-term trends of climate change. The station is one of our most important tools for taking the pulse of our own planet. The breadth of science conducted is astonishing. It ranges from growing protein crystals in microgravity to create better drugs on Earth, to testing new materials in the harsh environment of space, to studying the fundamental nature of fire without the influence of gravity-driven convection. Each experiment, large or small, adds another piece to the vast puzzle of our universe. By 2018, the station had hosted thousands of experiments from researchers in over 100 countries. It had fulfilled its promise, becoming a true journey of knowledge and a testament to what we can achieve when we build a laboratory in the heavens for the benefit of all humanity. The International Space Station is more than a magnificent machine. It is a living story, a narrative written in the sky. The ISS stands as a testament to what we can accomplish when we choose cooperation. Its legacy is measured in scientific discoveries and moments of human connection. This orbiting outpost is our generation's great monument to curiosity and peace. The research has led to tangible benefits back on the ground. The station's observation of our planet has provided data for understanding climate change. Perhaps the most powerful legacy of the ISS is the inspiration it provides. It has captivated a generation, encouraging young people to pursue careers in science. It shows us a future where our shared identity as Earthlings is more important. Through it all, the partnership held strong and the mission endured. It is a beacon of discovery, a testament to the human spirit. The International Space Station continues its orbit, a hub for science and international collaboration. Extended to at least 2030, it's our primary platform for learning to live and work in space. The ISS is a stepping stone for solar system expansion and future missions to the Moon and Mars. It's a key part of the new space economy, fostering commercial partnerships and private space stations. Even as we plan its deorbit, the knowledge from the ISS will echo for centuries. The ISS is the essential bridge to our multi-planetary future. It's a symbol of achievement and a beacon for our aspirations, representing the best of international cooperation. The International Space Station is our foothold on the final frontier, our first permanent home among the stars.